Hey people, get ready to crush everyday TOEFL iBT tests for all modules and make your dreams come true. I'm your motivator and I'll be guiding you through the test prep videos. So don't forget to like, share, and subscribe or you'll be missing out on some serious preparation.
Conversation 1. You will hear a conversation. A female student visits the university library reference desk to get help with research for a history paper. She speaks with Marcus, a male reference librarian. First, you have some time to look at the 5 questions. Now listen carefully and answer the questions. Excuse me, hi. I was hoping you could help me. I'm working on a research paper for my American history course and I'm having a really hard time finding sources.
Of course, that's exactly what we're here for. What's the topic of your paper?
It's about the economic causes of the Dust Bowl in the 1930s. My professor wants us to use at least 4 primary sources, but I've only been able to find one so far, and it's just a newspaper article from that time.
Oh, that's actually a rich topic with plenty of available material. The challenge is knowing where to look. Have you tried the library's digital archive portal yet? We have access to several historical newspaper databases, including ProQuest Historical Newspapers, which goes back to the late 1800s.
I didn't know about that. I've only been using the general search engine on the library homepage.
That's a very common mistake. The general search is great for secondary sources, books, journal articles, that sort of thing, but for primary sources you really want to go into the specialized databases. Let me show you. So, if you log into the portal here and navigate to the Primary Source Collections tab.
Oh wow, I didn't even see that tab before.
It can be easy to miss. Now, for your topic, I'd recommend 3 collections in particular. First, the ProQuest Historical Newspapers I mentioned. Second, the Library of Congress's Chronicling America database, which is free and publicly available, you can access it from home too. And third, we have a subscription to Fold 3, which contains government documents and congressional records. You might find federal agricultural reports from the 1930s very useful there.
That's incredible. I had no idea there were so many resources. But honestly, I'm a little worried I won't know how to evaluate whether a source is actually a primary source or not. Like, how do I know the difference?
That's a really insightful question, and it trips up a lot of students. A primary source is something created at the time of the event by someone who witnessed or participated in it directly: a diary, a letter, a government report, a photograph, a contemporary newspaper article, even a speech transcript. A secondary source, on the other hand, is an analysis or interpretation of those events written after the fact, like a history textbook or a scholarly article.
Okay, so the newspaper article I already found would count as a primary source because it was written during the Dust Bowl?
Exactly right, as long as it was published between, say, 1930 and 1940 and isn't itself a retrospective analysis. You're already on the right track. Now, I'd also suggest checking out the oral history collections we have. We have recordings and transcripts of interviews with actual Dust Bowl survivors that were conducted as part of the Federal Writers Project. Those make compelling primary sources.
Oh, that would be amazing for my paper. Can I access those online too? Some of them, yes. Others are only available in the special collections room on the 3rd floor. You'd need to make an appointment to view those. I can give you the contact information for the special collections librarian if you'd like. Yes, please. I think I have enough to get started now. Thank you so much, this has been incredibly helpful. I was really stressed about this assignment.
Happy to help. And if you run into any trouble navigating the databases, don't hesitate to come back or send us an email. We also have research help appointments if you want a full one-on-one session, those run about 45 minutes.
I might take you up on that. Thanks again, Marcus. That is the end of the conversation one. You now have some time to answer the questions. Conversation 2. You will hear a conversation. A male student visits the office of his academic advisor, Dr. Patricia Osei, to discuss a problem with his current course schedule and a possible change of major. First, you have some time to look at the 5 questions. Now listen carefully and answer the questions.
Hi, Dr. Osei. Thanks for seeing me on short notice. I know I didn't have an appointment.
No worries at all, Daniel. I had a cancellation this morning, so the timing worked out perfectly. Come on in. What's going on?
Well, there are actually 2 things I wanted to talk about. The first is kind of urgent. I'm having a serious conflict with one of my courses this semester. I'm registered for Chemistry 240, the organic chemistry lecture, but it completely overlaps with the lab section for Biology 310 that I need for my major requirements.
Oh, I see. That is a problem. How did that happen? Didn't the registration system flag the time conflict?
It should have, but I registered for the chemistry lecture during the early registration window, and then the Biology 310 lab section I needed was only added to the schedule after that. So by the time I registered for the lab, the system had some kind of glitch and let me through anyway.
That's frustrating. Okay, let's see what we can do. Is there another lab section for Biology 310 that doesn't conflict?
I checked, and there's one on Thursday afternoons, but it's already full. There's also a Friday morning section, but I have a part-time job on Friday mornings that I really can't give up right now.
I understand. Here's what I can do. I can send a permission override request to the biology department to see if they'll allow you into the Thursday section even though it's listed as full. Instructors sometimes make exceptions, especially when the conflict is due to a system error rather than a student's own planning.
That would be really great. I didn't know that was an option.
It's not guaranteed, but it's definitely worth trying. I'll send that email today. Now, you mentioned there was a second thing you wanted to discuss?
Yeah, this one is a bigger deal, honestly. I've been thinking about changing my major. I'm currently a biology major, but I've been seriously considering switching to environmental science.
That's a significant decision. What's prompting this?
I took an elective last semester, Environmental Policy and Sustainability, and it completely changed how I think about science. I realized I'm more interested in how scientific knowledge gets applied to real-world environmental problems, like policy, conservation, land use. Pure biology feels too narrow to me now.
I can understand that. Environmental science is a great interdisciplinary field. Before you make any decisions, let me pull up your transcript so we can do a proper audit. The good news is that many of your current biology credits will likely transfer toward the environmental science requirements. Let's see, yes, your general biology sequence, your statistics course, and your chemistry courses all count. You'd essentially be adding coursework in earth sciences, ecology, and environmental policy.
So I wouldn't be starting over completely?
Not at all. Based on what I'm seeing, you might only need 4 or 5 additional required courses beyond what you've already taken or are currently enrolled in. Depending on your pace, you could still graduate on time, possibly even within the same 4-year window.
That's a huge relief. I was worried I'd have to add another whole year.
It's possible in some cases, but yours looks manageable. I do want to caution you, though, before you make it official, I'd strongly encourage you to speak with Professor Alvarez in the Environmental Science Department. She advises prospective majors, and she can give you a very clear picture of what the program demands and what career paths it opens up.
Yeah, that makes sense. I don't want to make this decision without getting as much information as possible.
Exactly. And if after talking with her you want to go ahead, the change of major form just needs both department signatures and then my sign-off. It's a straightforward process. Why don't we schedule a follow-up appointment for 2 weeks from now so we can revisit this once you've had that conversation?
That works perfectly. Thanks so much, Dr. Osei. I came in here really stressed out and I feel a lot better now.
That's what I'm here for. I'll get that override request sent out before the end of the day.
That is the end of the conversation too. You now have some time to answer the questions. Lecture 1. You will hear part of a lecture about linguistics. Creole language development. First, you have some time to look at the 6 questions. Now listen carefully and answer the questions.
Alright, let's get started. Today we're going to talk about Creole languages, a fascinating subject in linguistics that touches on questions of identity, contact between cultures, and how human language adapts under extraordinary social pressure. A Creole language is a stable, fully developed natural language that originates from a pidgin, that is, a simplified contact language, and then becomes the native tongue of a community of speakers. The critical distinction here is that a pidgin is nobody's first language, it's a functional bridge between groups. But when children grow up hearing a pidgin and begin acquiring it as their mother tongue, something remarkable happens. That, something remarkable, is what linguist Derek Bickerton called the language bioprogram hypothesis. Bickerton argued that when children creolize a pidgin, they don't simply expand its vocabulary, they supply grammatical structures that weren't present in the original pidgin, structures that seem to reflect universal properties of human language. He studied Hawaiian Creole English extensively and found that children added tense aspect markers, embedded clauses, and articles with systematic consistency, even without a grammatical model to follow. This led him to propose that the human brain has an innate linguistic template that kicks in when input is insufficient. Now, the social contexts in which Creoles develop are really important to understand. Historically, many Creoles emerged on colonial plantations, in the Caribbean, in West Africa, in the Pacific, where enslaved or indentured people speaking dozens of mutually unintelligible languages were forced into contact with a dominant colonial language, such as French, English, Portuguese, or Dutch. The result was a pidgin used for basic communication. Over 1 or 2 generations, that pidgin became a Creole. Haitian Creole, Tok Pisin in Papua New Guinea, Papiamentu in the Dutch Caribbean, these are all examples of thriving Creole languages with millions of speakers.
Student, Professor Hartwell, I'm a little confused about something. If Creoles develop from pidgins, and pidgins come from contact between a colonial language and local languages, does the Creole end up sounding mostly like the colonial language? Or does it preserve features of the local languages too?
That's a really perceptive question, and it's actually one of the central debates in Creole studies. The vocabulary of a Creole, what linguists call the lexifier, tends to come predominantly from the colonial, or superstrate, language. So most of the words in Haitian Creole are recognizably derived from French. But the grammar, the phonology, and many semantic structures often reflect influence from the substrate languages, in Haiti's case, the West African languages spoken by enslaved people, particularly Fon and Yu. So in a sense, a Creole is a synthesis. It borrows its words from one source and its underlying grammatical logic from another. This substrate influence is why different Creoles based on the same colonial language can sound and function quite differently from one another. I also want to address something we touched on briefly last week, the continuum. In many Creole-speaking communities, you don't just have one fixed language, you have a range of varieties on a spectrum. At one end is the Baselect, the variety furthest from the colonial standard. At the other end is the Acrolect, which closely resembles the standard colonial language. And in between is the Mesolect. Speakers shift along this continuum depending on context, social setting, education, audience. This dynamic is especially visible in Jamaica, where Jamaican Creole, locally called Patois, coexists with standard Jamaican English, and speakers navigate between the two fluidly.
That is the end of the lecture 1. You now have some time to answer the questions. Lecture 2. You will hear part of a lecture about art history. Impressionism movement. First, you have some time to look at the 6 questions. Now listen carefully and answer the questions.
Good morning, everyone. Today we're turning to one of the most celebrated and, in many ways, most misunderstood movements in Western art history, Impressionism. When people today hear the word Impressionism, they likely think of soft, beautiful paintings of sunlit gardens and shimmering water, pleasant, accessible, universally loved. But I want you to hold that image in your mind and then set it aside for a moment, because when Impressionism first emerged in Paris in the 1860s and 1870s, it was considered scandalous, amateurish, even laughable by the artistic establishment. Understanding why requires us to understand what the establishment looked like. The dominant institution governing fine art in France at the time was the Académie des Beaux-Arts, which organized the annual Salon, the most prestigious exhibition in the Western art world. The Salon had strict standards: paintings should be large-scale, historically or mythologically themed, executed with invisible brushwork and perfectly smooth surfaces. Artists were trained for years to suppress any evidence of personal gesture in their work. Then along came a group of painters: Monet, Renoir, Pissarro, Berthe Morisot, Degas, Sisley, who did almost the exact opposite. They painted outdoors, capturing fleeting moments of modern life: cafes, racetracks, riverbanks, crowded boulevards. They used short, broken brushstrokes and bold unmixed colors, leaving the surface of the canvas visibly textured. The name Impressionism itself was originally an insult. In 1874, this group held their own independent exhibition, the first of 8, outside the Salon system. One of Monet's paintings, titled Impression, Sunrise, caught the eye of a hostile critic named Louis Leroy, who sarcastically titled his review Exhibition of the Impressionists, using Monet's title to mock the entire group as producers of mere impressions rather than finished works of art. The painters, remarkably, adopted the label and wore it proudly. It became one of history's great examples of a derogatory term being reclaimed by its targets.
Student, Professor Beaumont, I read that some of the Impressionists, like Degas, didn't actually paint outdoors very much. Does that mean he wasn't really an Impressionist?
Excellent point, and it gets at something important about how we use the term Impressionism. You're absolutely right that Edgar Degas rarely painted en plein air, which is the French term for painting outdoors. He preferred working in his studio, and his subjects, ballet dancers, laundresses, women bathing, were often observed from unusual angles, giving his work a candid, almost voyeuristic quality. He's sometimes called an independent rather than a strict impressionist. What united him with the group was less technique and more attitude, a rejection of the Salon's academic hierarchy, an interest in modern urban life, and a commitment to depicting experience as it is actually perceived rather than as idealized convention demands. So Impressionism is best understood as an umbrella term for a loosely affiliated group of innovators rather than a rigid, unified style. I also want to spend a moment on 2 technical innovations that were crucial to the movement. First, the development and commercialization of portable tin paint tubes in the 1840s, something we rarely discuss, made outdoor painting genuinely practical for the first time. Before tubes, artists had to grind their own pigments and work quickly with bladder-stored paints, making sustained outdoor sessions nearly impossible. The tube liberated painters from the studio. Second, the Impressionists were deeply influenced by Japanese woodblock prints, ukiyo-e, which flooded European markets after Japan opened its ports in the 1850s. These prints offered flat planes of color, unconventional cropping, and diagonal compositions that challenged Western perspectival traditions. Monet collected hundreds of them. Their impact on Impressionist composition and color theory was profound and lasting.
That is the end of the lecture 2. You now have some time to answer the questions. Lecture 3. You will hear part of a lecture about astronomy. Neutron star properties. First, you have some time to look at the 6 questions. Now listen carefully and answer the questions.
Let's move on to one of the most extreme objects in the known universe, neutron stars. A neutron star forms when a massive star, roughly 8 to 20 times the mass of our Sun, reaches the end of its life and undergoes a core collapse supernova explosion. During that collapse, the core is compressed so violently that electrons and protons are forced together, producing neutrons. What remains is an extraordinarily dense remnant composed almost entirely of neutrons and packed into a sphere roughly 10 to 13 kilometers in radius. To put that in perspective, a neutron star can contain up to 2 solar masses, 2 times the mass of our entire Sun, compressed into a ball roughly the size of a mid-sized city like Chicago. That extreme density produces gravitational and physical properties that strain the limits of our theories. The surface gravity of a neutron star is approximately 200 billion times that of Earth. The density at the core is so high that we genuinely do not know what state matter exists in there. We have competing models, including hyperons, quark-gluon plasma, and strange quark matter, but none has been confirmed. What we do know from observation is that neutron stars rotate extremely rapidly, emit powerful radiation, and possess magnetic fields that are trillions of times stronger than Earth's magnetic field. Many of these properties are observed in a specific class of neutron stars called pulsars. Pulsars were discovered in 1967 by graduate student Jocelyn Bell Burnell, working under Anthony Hewish at Cambridge. Bell Burnell detected a radio signal pulsing with extraordinary regularity, every 1.3373 seconds, and the signal was so precise that the team initially jokingly designated it LGM-1, for Little Green Men, half wondering if it might be artificial. It was, of course, a natural phenomenon, a rapidly rotating neutron star whose magnetic poles emit beams of radio waves. As the star rotates, those beams sweep across space like a lighthouse beam, and if Earth lies in the path of the sweep, we detect a pulse. The faster a pulsar rotates, the more regular and rapid the pulses. Some millisecond pulsars, which have been spun up by accreting matter from a companion star, rotate hundreds of times per second with a regularity rivaling atomic clocks.
Student, Professor Yellerin, when you say the core might contain quark matter, does that mean neutron stars could possibly be even denser than we currently think? Like, could there be something even more extreme?
That is exactly the right question to be asking, and yes, the short answer is we don't know, and that's what makes it so exciting. If the density at a neutron star's core is high enough, it's theoretically possible that neutrons themselves break down into their constituent quarks, forming a state called quark matter or strange matter. If that's the case, the star would be even denser than our standard neutron star models predict. Some theorists argue there might be a class of objects called quark stars or strange stars that are distinct from neutron stars, though no confirmed observation has yet established their existence. What we do know is that the upper mass limit for neutron stars, beyond which they collapse into black holes, is somewhere between roughly 2 and 3 solar masses, and the precise value depends critically on the equation of state of matter in the core, which is still an open problem in nuclear astrophysics. I want to close by briefly touching on magnetars, which represent perhaps the most extreme subclass of neutron stars. Magnetars have magnetic fields up to 1,000 times stronger than ordinary pulsars. We're talking fields on the order of 10 to the power of 15 Gauss. Such fields are so powerful that they distort the electron clouds around atoms and can generate enormous bursts of X-ray and gamma radiation. Magnetar flares have been detected from tens of thousands of light-years away and, in at least one case from the magnetar SGR 1806-20, a 2004 burst was energetic enough to partially ionize Earth's upper atmosphere despite originating roughly 50,000 light-years distant. That event released more energy in a fraction of a second than our Sun emits in 150,000 years, an extraordinary demonstration of just how physically extreme these objects are.
That is the end of the lecture 3. You now have some time to answer the questions. That is the end of the TOEFL iBT listening test. You now have some time to review your answers.
Hey people, how was your test? Don't forget to like, share, and subscribe, or you'll be missing out on some serious fun. See you tomorrow!